Today, we will explain what the cosmic microwave background is, and why it represents one of the most important pieces of evidence for the Big Bang theory. Shortly after the Big Bang, the universe was extremely hot and dense. Matter existed in the form of ionized plasma composed of protons, electrons, and photons. Photons constantly interacted with free electrons, causing scattering and changes in their direction, which prevented light from propagating over large distances. As a result, the universe was optically opaque. As the universe expanded, its temperature gradually decreased. Approximately 380,000 years after the Big Bang, electrons combined with protons to form neutral atoms. At this point, the universe became optically transparent to electromagnetic radiation, and photons were able to travel freely through space for the first time. The cosmic microwave background is electromagnetic radiation composed of these photons, which have been traveling through the universe ever since. Interestingly, the existence of the cosmic microwave background was predicted theoretically long before it was experimentally confirmed. Models of the hot Big Bang predicted the presence of a pervasive electromagnetic radiation, with nearly the same intensity in all directions. Due to the expansion of the universe, this radiation was expected to cool significantly and become observable today in the microwave region, with a temperature of only a few Kelvin. Experimental confirmation of the cosmic microwave background came in 1965. At that time, physicists Arno, Penzias, and Robert Wilson were working with a highly sensitive microwave antenna and detected a weak signal arriving from all directions of the sky, with nearly uniform intensity. This signal could not be explained by any known source of noise or instrumental error. Subsequent analysis showed that its properties matched the theoretical predictions for the cosmic microwave background. The discovery of the cosmic microwave background was of fundamental importance because it provided direct evidence of a hot and dense phase in the early universe. The cosmic microwave background is observed from all directions, has nearly uniform intensity, and corresponds to radiation, with a temperature of approximately 2.7 Kelvin. Alternative cosmological models that assumed a static and unchanging universe could not naturally explain the existence of such radiation. For this reason, the discovery of the cosmic microwave background became one of the most important experimental confirmations of the Big Bang model and a cornerstone of modern cosmology.